Okay, so I think we can start. So I'm sharing the screen. So is the screen visible to all of you? Okay,
Yes.
perfect. So in our previous class, we had begun with our discussion of the likelihood ratio test, right? What is the likelihood ratio test for finding out the best critical region for a hypothesis? And we had started with this question over here. So the first step, as I remember I had discussed, was to find out the maximum likelihood estimates of the mu hat and sigma square hat using MAD. So anyone give it a try? Or any other questions if anyone has on the previous classes discussion? Okay. All right. So maybe then we can start with this question from the very beginning today. Okay. So let me quickly extract it out.
Can you just tell me the date of the previous class? This class.
Date. You can check it once. I think it was 22nd Feb, but you need to cross check it with the portal.
Okay, okay. Thank you.
Okay. Yeah. So let's move on. So in order to perform the likelihood ratio test, the first thing that we need are the maximum likelihood estimates of both mu and sigma, right? Because it is given that mu and sigma both are unknown for performing this hypothesis. So can anyone tell me how we can find that out? What was the process? Anyone remembers? Okay, maybe then we can revise that first and then come over here. So the first thing that I'm asking you is that given this question that x1, x2 dot xn is a random sample from normal mu sigma square population, we want to find the maximum likelihood estimates of mu and sigma square. Okay. So first of all, what we need to write down the density function. What is the density function of the normal distribution? 1 by sigma root over 2 pi e to the power minus half x minus mu by sigma whole square, where x varies from minus infinity to infinity, right? So since x1, x2, xn is a random sample from normal mu sigma square, all the fx size will have this same distribution, minus half xi minus mu by sigma whole square, where minus infinity to infinity for all I. Correct? From here, we need to define the likelihood function, which is a function of mu comma sigma square given all the x values, right? Which is a product of the density functions. So that will be what? It will be product of I running from 1 to n, 1 by sigma root over 2 pi e to the power minus half xi minus mu by sigma whole square. So if you look at the first part, 1 by sigma root over 2 pi, this part is the same for all the terms in the product. So when you club all of them together, after you take the product, that would be 1 by sigma root over 2 pi whole to the power n. And the x power in the exponent is changing. So when you add all of them up, it will multiply. So that will become e to the power minus 1 by 2 sigma square summation xi minus mu whole square. Is this okay with all of you? Any questions from anyone? Is this understood? The likelihood function?
Yes, sir.
Then comes defining the log likelihood function. Which is small l as a function of mu comma sigma square. So that would be minus n log of sigma root pi minus 1 by 2 sigma square summation xi minus mu whole square. So that can be written as minus n log sigma minus 1 by 2 sigma square summation xi minus 2 sigma square plus the constant that you get from n and root 2 pi. Okay, understood by everyone? So this is your log likelihood function. So what will you do for finding out the MLE? For MLE, you would want to maximize the log likelihood function with respect to mu and sigma. So partially differentiating L with respect to mu, setting it equals to 0, and partially differentiating small l with respect to sigma and setting it equals to 0. Correct? This is what we'll be doing. Okay. So what will be the first one? When you differentiate with respect to mu, this expression, the last line that we have got, minus n log sigma minus 1 by 2 sigma squared summation xi minus mu. So when you differentiate, n log sigma will be 0 minus 1 by 2 sigma squared 2 times summation xi minus mu is equals to 0. Correct? So this 2 and 2 will get cancelled out, and since sigma square is not 0, so that implies summation xi minus mu is 0. So what is your mu hat MLE? It is the sample mean x bar. Can all of you follow this calculation? I have skipped a step in between because we have already discussed this once. So is it okay? Understood by everyone?
Yes, sir.
Others, any questions? Okay, perfect. Now coming to the second one, partially differentiating small l with respect to sigma. So that will be minus of n by sigma, and this would be minus half, and this is sigma square, so minus 2 by sigma cube summation xi minus mu whole square. Correct? So 2 and 2 will get cancelled, and you're eventually left with, if you push that to the right side, so that means sigma square is nothing but 1 by n summation xi minus mu whole square. Okay, or in other words, this is the sigma hat MLE. Okay, any questions from anyone?
Sir, how n by sigma became positive?
If you take it to the right side, the second term will become positive. So if you take n by sigma to the right, it becomes
Oh,
positive.
okay.
Any other questions from anyone? Is it fine? Now, two things over here. I just want to mention that over here, check that the MLE for sigma square contains mu, right? So if mu is known, then this is fine. This can be the maximum likelihood estimate. However, if mu is not known, then you cannot keep mu in the expression, right? Because an estimate should be something that you can directly compute out of the sample, right? You cannot have any unknown population value in the estimation formula. So that means, but if sigma square is, if mu is unknown, then what will we do? We will replace mu by its maximum likelihood estimate that we have already found out. So that will make what? Sigma hat square MLE is equals to 1 by n summation xi minus x bar whole square. Okay, correct? Depending on the situation, you will have to choose your appropriate estimator for sigma square. If mu is known, then the previous one. If mu is unknown, then this second one. All right, is it fine? So these are the likelihood MLE estimates of mu hat and sigma hat. Now, why did we need them? If I just go back to our previous classes content, what did the likelihood ratio test talk about? That we want to define, we want to find out whether this ratio, lambda, which is the maximized value of L for theta belonging to omega naught by maximized value of L for theta belonging to omega, is less than some critical value lambda naught or not, right? So let me just define it once more for all of you. Over here, what is the hypothesis that we want to test? H naught mu equals to mu naught, and we have a finite variance versus H1 mu not equals to mu naught, and we have a finite variance. Okay. So this is your parameter space. Mu equals to mu naught, and this is the specific omega naught that we are talking about. Okay. So this is the specified parameter space under the null hypothesis. And what is the overall parameter space? Mu can take any value between minus infinity to plus infinity, and sigma square can take any value between 0 to infinity, right? So that is the thing. So the first of all, what we want to find out is that, so let me just write this down. So what is sigma naught? It is basically mu equals to mu naught, and 0 less than sigma less than infinity. And what is the overall parameter space? Mu can take any value between positive infinity to infinity, and sigma squared can take any value between 0 to infinity. Okay. Therefore, if you substitute the maximum likelihood estimate values in the likelihood function expression, what will you get? You will get the maximized value of the likelihood function. Correct? So, if I want to find out the maximized value of L under the parameter space omega, that will be what? It will be basically the value of the likelihood function when you replace mu hat MLE and sigma square hat MLE. Do all of you agree to this? Yes? Is it making sense? For the likelihood ratio test, you want to take the ratio of the maximized value of the likelihood under two situations. In the first one is in the general parameter space, and another one is the omega naught, which is the parameter space under the null hypothesis. So we first need to compute that expression, that what is the maximized value of the likelihood function. So what did you do? You are trying to find that out. So we have the likelihood function expression. We are going to compute the maximized value in this way. So first of all, let me write down the likelihood function once more. So what is your L of mu comma sigma square? It is 1 by sigma root over 2 pi whole to the power n e to the power minus 1 by sigma square summation xi minus mu whole square. Correct? So what will be the value of the likelihood function under mu hat MLE and sigma square hat MLE? Can anyone tell me? So you will replace these two expressions over here, the mu hat MLE and sigma square hat MLE. Correct? Agreed? So this is the expression for mu hat MLE. And in the general parameter space, since both mu and sigma are unknown, this is your sigma square hat MLE. Okay, so I'm just writing it on the side. So what is your mu hat MLE? It is x bar. And what is your sigma square hat MLE? It is 1 by n summation xi minus x bar whole square. And maybe we can call it as s square. That's fine. Okay. So we will replace these values over here. So basically that will be sigma hat under root 2 pi whole to the power n e to the power minus 1 by sigma hat square summation xi minus mu hat whole square. Okay, agreed? So now what are we getting? We need to say, we can simplify this a little bit. So this will be basically do all of you agree? The exponent part is the same. In order to make it sigma square over here, I have taken n by 2 in the power. Is this understood by everyone?
Yes, yes.
Correct? Now, if you can replace first the mu hat value, going step by step. So that is 1 by sigma hat square 2 pi n by 2 e to the power minus 1 by sigma hat square summation xi minus x bar whole square. Okay. So we replaced mu hat first as x bar. All right. This was the mu hat that is being replaced as x bar. The next thing is replacing sigma hat. So for sigma hat, what we'll do? So that is 1 by, in the place of sigma hat square, you will be writing s square 2 pi to the power n by 2 e to the power minus of, this will become n by 2. Why so? Because what is summation xi minus x bar whole square? This is ns square. And you will be replacing this sigma hat square in the power with s square. So that will cancel out and you will be left with minus of n by 2. Okay, can all of you confirm if you understand this calculation? Is it fine?
Yes.
Okay, so what is this? This is the maximized value of the likelihood function, right? Under general conditions. So this is the maximized value of the likelihood function. Okay, and under general condition means what? Under the general parameter space. So this can be your L of omega. All right, or rather you can write L max of omega, whatever feels comfortable. The maximum value of the likelihood function under the general parameter space. Okay, is it fine? Any questions from anyone? So we have got one value that we need, the value in the denominator, right, of the ratio. Now we need the numerator. What we need to find out? The next step is to find the maximized value of L under the omega naught parameter space, the one that is specified in the null hypothesis. Correct? And what is the omega naught parameter space? It is specifying the value of mu equals to mu naught, and sigma square can vary anywhere between 0 to infinity. Correct? So you want to find out the maximized value of the likelihood function under this parameter space. Correct? So L max of omega naught. This is what we want to find out. Now note something over here. Under this omega naught set, obviously, in order to find out the maximized value of the likelihood function, you need to replace the maximum likelihood estimates of mu and sigma, right? Similar to what we had done in the previous step. But under this set, you don't have two variables. Mu is given, right? Mu is a known value under sigma naught. Mu equals to mu naught, right? This is the value. So this is known. So that means under sigma naught, the only value that you don't know, it's sigma square. All right. So that means the L max of lambda naught would be the likelihood function evaluated by replacing mu equals to mu naught and the maximum likelihood estimate of sigma square, since mu is known under omega naught. Can all of you follow this argument? If anyone has any questions, you can ask me. Okay. So since mu is known under this set, you need not replace it by any of its estimates. So you can simply put down mu naught in the place of mu, and you will be replacing the maximum likelihood estimate of sigma square. But again, under this mu is known, right? So what is the likelihood estimate of sigma square that you will choose? The first one. Am I correct? All of you agree? It will be summation xi minus mu whole square, not the x bar one. You know mu, so you can simply put that in the expression and get to the estimate. So I'll just write one more line over here, that the maximum value would be the likelihood function evaluated under this condition, where what is your sigma hat square MLE? It is 1 by n summation xi minus mu naught whole square. Okay, do all of you agree? Can you please confirm me with a yes or a no if this is fine? Understood?
Yes.
Okay, so just like we told that is s square, so let's say that is s naught square, something. Okay, so the likelihood function that therefore that which would be 1 by sigma hat square 2 pi to the power n by 2 e to the power minus 1 by 2 sigma hat summation xi minus mu naught whole square. Correct? This is what it will be. And then you would replace the value of sigma hat square everywhere. So that is 1 by s naught square 2 pi to the power n by 2 e to the power minus, again it will replace, and that will become n by 2. Okay, got it? Anyone, any questions? Is it fine? So now that means what? So we have got the two values, right, that we required. So now for the likelihood ratio test, we will define this ratio lambda, right, which is the maximized value of the likelihood function under the restricted parameter space H naught divided by the unrestricted one. Can all of you quickly replace these two values and tell me what you're getting?
A square by S not square
Repeat once more, sorry. S square by,
is not square.
I guess something more. The power n by 2.
Uh, yes, it will be good.
Yes, correct. So that will be S square by S naught square divided by n by 2 or minus n by 2. What is it? N by 2, right? Yes. This is what you're getting. Is it understood by everyone? Any questions? Is this answer matching for everyone? Okay. So for the best critical region now, what we should do? For the best critical region under likelihood ratio test, we want to find a lambda naught such that lambda is lesser than lambda naught. Correct? This will be the best critical region for the test. Okay, is it understood by everyone?
Yes.
Okay. And how will you find this lambda naught? You will find this out from the level of significance, right? And to evaluate this, we need this, that the probability that lambda less than lambda naught given h naught is equals to alpha, right? So before finding out the best critical region, you fix the level of significance. So that will help you with finding lambda naught. All right. Is the process understood by everyone? Any questions? Any doubts to be clarified? All right. Perfect. So if I hope all of you have understood the sequence of steps that we are doing and how we are working them out. That will be important. Okay. So if this is fine with all of you, let's move on to the next question, or rather an extension of this only in some sense. Next one. Let x1, x2, xn be a random sample from normal mu sigma square. All right. So we want to find the best critical region using the likelihood ratio test for testing h naught mu equals to mu naught comma finite variance versus h1 mu greater than mu naught and finite variance. Okay, where both mu comma sigma square are unknown. Okay. So this is the question. So can anyone first to start with, can all of you please tell me that what is the unrestricted parameter space, that is the overall one, and what is the parameter space under null hypothesis? What is it?
So for omega, it is mu minus infinity to infinity, and sigma square also minus infinity to infinity.
I 0 to infinity. Positive.
Yeah. Sorry, 0 to infinity.
Hmm.
And for omega naught, it would be mu naught to infinity.
Mu naught to infinity or only mu naught?
So
Under null hypothesis, right? So mu equals to mu naught. Omega naught is basically representing the possible values of mu and sigma square under h naught.
oh, okay.
So under h naught, mu is mu naught, that is given. So mu is equals to mu naught and sigma square lies between 0 to infinity.
So the formulation between this and above question is exactly same.
Yes, the sets are the same. Okay. Because typically, you can see that the null hypothesis is the same, right? The alternative has changed. So that will not influence your choice of omega and omega naught. Omega naught is constructed out of the null hypothesis, and omega is the general overall possible parameter space. Correct?
Yeah.
So that is why this will remain the same. And now we can understand that obviously, if you just do a little bit of back calculation in some sense, that we need the MLE estimates, we will replace it accordingly. So those are the steps that we need. All right. So in general, you will not be required always to work out that entire calculation that I have shown you for finding out the MLEs. Okay. It's you can directly use them as well. All right. So I just did that as a revision or a recap. So we need mu hat and sigma hat square. Correct? These are the two MLE values that we need to replace when we are working out or trying to find out the maximized value of the likelihood function. Correct? Now, let me just write down one thing. Do all of you agree that what would be mu hat MLE? It would be x bar if mu is greater than equals to mu naught, and it would be simply mu naught if mu is less than equals to mu naught. Correct? Do all of you agree to this? I will be replacing the estimate of mu for only that part for which I don't know the value of mu, right? What is that part of the value of mu that I don't know? The range where mu is greater than mu naught. That is where I don't know a possible value of mu. So only for that part I will be replacing it by x bar, and the remaining I will do as mu naught. Okay. And in the exact same way, what would be sigma hat square MLE? You will be replacing it with s square when mu is greater than mu naught, because you don't have the value of mu, and it will be s naught square when mu is less than mu naught. Where what is s square and s naught square? I will define it once more. That is, s square is 1 by n summation xi minus x bar whole square, and s naught square is 1 by n summation xi minus mu naught whole square. Okay. Is this understood by everyone? Any questions?
Sir, can you please explain the inequalities once again? I couldn't understand like how like we are varying mu for two different values.
Okay, Chaitanya. Come to the previous question. When you were finding out the maximized value of the likelihood function under omega, the general parameter space, you did not know mu and sigma, right? Both were unknown. So you replaced both the values.
Correct.
Correct? And when you came to a similar story under omega naught, mu was known. You are aware of the value of mu, right? So you did not replace the likelihood estimate, or in other words, I can say that the likelihood estimate was mu naught, right? Another way to put it.
Yeah.
Yeah. So, and the sigma square estimate was chosen accordingly. So over here in this question, what I am saying is that look at the hypothesis. H naught mu equals to mu naught and H1 mu greater than mu naught, right? So focus on these two first. So obviously you need to replace the maximum likelihood estimate of the two parameters, mu and sigma square. Okay. So what you can see is that you don't know the exact value of mu under the alternative hypothesis, correct? So for that region, mu greater than mu naught, you will be replacing mu by its actual likelihood estimate, x bar. And for the region for which you know the value of mu, you will be simply taking it as given. Okay.
Yeah.
All right. And the same story goes for sigma square. If you look at the alternative hypothesis, mu greater than mu naught, in that part, you neither do you have a particular value of mu, nor do you have a particular value of sigma square. So you need to take the maximum likelihood estimate as 1 by n summation xi minus x bar, which is s square. And that will be chosen as an estimate when mu greater than mu naught. And for mu less than mu naught, you know mu, right? So mu naught. So you will be choosing the s naught square value as your estimate, likelihood estimate. Okay.
So this is all under null hypothesis. So
Yeah, like not necessarily. Like this part is under to the. So you can say this way that the mu hat MLE, the first line is under H1 and the second line is under H0. Under H1, mu is greater than mu naught, so the chosen value of the likelihood is x bar. For H0, mu is equals to mu naught.
got it. Yes.
Okay, you can think of it in this way. Although you shouldn't write it in this way. That's not correct to write it in this way. Okay, so I'm just rubbing this off. Others, have you all understood?
Sir,
Yes.
sir, just can you please explain the first line, the omega equal to minus infinity less than mu less than infinity?
What is omega, Dipankar? It is the overall parameter space, right?
Yes,
All
sir.
possible values of mu and sigma square. So for a
Yes.
normal distribution, what will be that? Mu can take any value between minus infinity to plus infinity, and sigma square can take any value between 0 to infinity.
Yes. Okay, sir.
So that is omega. And omega naught is the parameter space under H naught. So under H naught, mu is fixed at mu naught, and
Yes.
variance can vary. So omega naught is mu equals to mu naught, variance varying between 0 to infinity.
Sir, just one more thing, sir. Yes, sir. Why you, no, sir, you just haven't written here mu greater than mu naught, and instead you have just wrote minus infinity less than mu less than infinity.
Once more, Dipankar, where?
No, sir, in the, sir, just the, what this is, sir, first line, it,
Omega definition.
no, sir, in the, sir, between the range of the omega, there must be, sir, mu greater than mu naught, but you have just written minus infinity less than mu less than omega, sir. Why it is so?
Because that is the overall range, right?
Oh, yes, sir.
Omega is the overall range. Why will mu greater than mu not come over there?
Yes. Thank you,
For
sir.
a normal variate, that is the case. So that is why. Okay.
Yes,
So
sir.
if you all have understood this, I would now request you all to try to proceed in the exact similar way as the previous question. Defining the maximized values of the likelihood function under omega and omega naught, trying to take the ratio and trying to see what you're getting. Okay. So I want you all to just give it a try, because if you all have understood the mechanism that's going around, then you should be able to replicate the same for this question. Okay. So I'll just write down this. So the next step would be to find the maximized value of the likelihood function under omega, the maximized value of the likelihood function of the omega naught, and then find lambda. By find, I mean calculate, obviously. Okay. So do give this a try, and we'll come back with the discussion of this in the next class onwards. Yes, Chaitanya?
Sir, so I was trying to understand the difference between the previous question and this one. In both of the cases, the likelihood ratio test is omega naught, likelihood of omega naught by L max of omega. So in the second part, like the latest part, why was it necessary to insert the second line? Because are we trying to do L max of omega naught by L max of omega under H1?
Why was it necessary to insert the second line? Second line of what?
Under mu MLE, we are saying that if mu is greater than mu naught, then it becomes x bar. So under omega naught, we would know that it is already less than mu naught, so we just keep it as mu naught. So I'm trying to understand
Why was it are you asking like why did I write this? Is that what you're asking?
Yes, yes.
To summarize what we discussed in the previous question. That's it.
Okay,
Nothing more than that.
okay. It won't be used in that sense.
Like used, like it will be getting used by because you'll be replacing the values, but like these two expressions that I have written basically summarizes the entire discussion that we have worked out in the previous question. That what values of the likelihood function you will be what values of the likelihood estimates that you will be replacing under different scenarios. That is what I've summarized over here. Nothing more than that.
Okay.
Okay.
Yep.
Okay.
Yep.
All right then. Stopping the screen share. Thank you all for joining. See you all in the next class. You all can disconnect.
Sir,
Yes.
sir, just 1 minute, sir. No, sir, just like, can you send the link of the mail of where we can send our doubts, sir? The spelling was wrong a little bit earlier, so my doubt hadn't been wished to you, sir. That's the main problem. Spelling mistake.
1 second.
Thank you, sir.
I'll just type it in chat. Yeah, I've given it on chat. You can take it down.
Thank you, sir.